All right, section 4.6, factoring polynomials by grouping. So just to review really quickly, factor if possible, if not, right, not factorable. So when you have a quadratic trinomial, which is what we have here in the first example, kind of what you're looking at is if you can take, well, first of all, you should always look for a greatest common factor, which there is none. But then you should take a times c, so we're taking 1 times -4, we get -4. If you can find a factor pair that adds up to your b value, which is -3 in this example, then you can factor. So really easy, 1 times -4 is -4. 1 plus -4 is -3. So that means, yes, I can factor. If you could not find this proper factor pair, then you would tell me it's not factorable. Hopefully you exhausted all your options before you get to that point, but that means that, yes, it would not be factorable. Because a is 1, I can use the shortcut, which makes this x plus 1 times x minus 4. Just a reminder, if a was not 1, like in the example below, if you could factor, you'd have to use the box. Off to the right here, 3x squared minus 12, so we have a quadratic binomial. And like I said, the first thing you should always check for is greatest common factor, which we can divide a 3 out of both of these. So we have 3, and then we have x squared minus 4. Anytime you take out a greatest common factor, you should try to factor further. Sometimes it's not possible. In this case, though, it is, because what we have here is one of those special cases. We are subtracting 2 perfect squares. So we can use a shortcut for this as well. So we'll go x times x is what gives us x squared. 2 times 2 is what gives us 4. One's positive, the other's negative. That's how we would factor the difference of squares, that special case there. And then the last example, just as a review. So like I said, take out the greatest common factor. So we can take out a 3 from all of these. So we're left with x squared minus 2x plus 1. Then we're going to take a times c. So a times c is 1, and we're looking for factors of 1 that add up to -2. How about -1 times -1? -1 times -1 is +1. If you add them up, you get -2, which means, yes, we can factor further. So we have 3. That's my greatest common factor. And because a is now 1 here, I don't need the box, so I could just go x minus 1 times x minus 1 from those two numbers right there. And hey, they're all factorable. What do you know? So Dory's list on how to factor. Love it. All right, so if we have a polynomial first, look for a greatest common factor. That's incredibly blurry, or great. I don't know what the next one says. I apologize. Factor is a product of binomials. If it's a special product, it's either going to be the difference of squares or the sum or difference of perfect cubes, which we talked about just last week. Factor by grouping, which we're going to do today, or it's not factorable at all. I'm very curious as to what the little sound would have been here. I'm going to have to go try to find this somewhere. So here's how factoring by grouping works. First, make sure your polynomial is in standard form, which it is. Then what you're going to do is you're going to group the first two terms. You're going to group the last two terms. Then what you're going to do is take out the greatest common factor. So looking at these two terms, what can I divide out of both of those? It looks like I can take a 9 and an x squared. So we're going to go 9x squared on the outside. And then what do we have left? We have x plus 2. Done with that. We're going to do the same thing here. What can I take out of these two terms? It looks like just a -4. So we'll go minus 4 times, and then what's left is x plus 2. Okay, so step number 1, make sure your polynomial is in standard form. Step number 2, group the first two terms, group the last two terms. Step number 3, take out the greatest common factor. That's where we're at right now. And then what you should have left is something kind of cool. You should, in parentheses, you should have the exact same thing left if you can factor by grouping, which in this case we have x plus 2, so we can. So final factored form already is going to be, well, not quite, I guess, 9x squared, so this outside number, minus 4, that outside number, times x plus 2, because they have that in common. So we're kind of just finding the greatest common factor again. And then what you should do is make sure you can't factor any further, but I notice here this first binomial, this quadratic binomial, is a special case, kind of like this one was up here. So what we can do here is we can write this as 3x and 3x. We'll go plus 2 minus 2 to get the b value to be 0. And then I still have my x plus 2. That would be final factor form. Once you're down to the linear expressions, the only thing you could take out is the greatest common factor, but none of these three terms, or none of these three binomials have a greatest common factor, so we're done. So kind of a lot thrown at you, but let's do a couple more here, and then I'm going to have you try the last two. So again, I think these are all going to be written in standard form, but it's just good to check. Group the first two, group the last two. Now we're just taking out the greatest common factor. So 3x cubed and 12x squared. We can take a 3x squared out. So we have 3x squared, and what's going to be left is x minus 4. Okay, now we should hope for the same thing left over when we take out our greatest common factor here. So we can take a 2 out. So we're going to go plus 2 because it's a positive 2. So you do have to include the sign here. Like this was a negative 4, so I made it minus 4. This was a plus 2, or positive 2 that I'm taking out here. So I'm going to make it plus 2. And then, like I said, we hope we get an x minus 4 left because we want this one and whatever we get here to be the same. So 2 divided by 2, so we get x minus, hey, well, what do you know? Worked out. So then we can factor, or we can rewrite this is really what we're doing. So we're going to take this outside number and this outside number. We're going to make that one group, so 3x squared plus 2. And then whatever we had left over, like I said, they have to be in common, otherwise you can't do this. So we're going to go x minus 4 for both of those, because that's what they had in common, and that's it. So we're kind of just taking the greatest common factor, the first term and the last term. So here we go, one more. So group the first two, group the last two. We can take out an x squared. So you have x squared, and then we're going to have x minus 5 left. And then over here, now again, your goal should be to get this exact same thing. It might be tempting, I'll just kind of show you here. It might be tempting to say, hey, we can just take a 9 out. So we'll go plus 9, and then left with negative x plus 5. All right, 45. Negative x plus 5. Now, do we end up with the same thing? Close, but no. So here's what we can do instead. We can say, hey, let's just divide both these by negative 9. So I'm going to take a negative 9 out now. And now negative 9x divided by negative 9 is positive x, so we're good there. 45 divided by negative 9 is negative 5. Hey, who would have guessed? Got the same thing again. And then again, rewrite this. So we'll take x squared minus 9 will be our first group here. And then x minus 5, because that's what they had in common. And then every once in a while, you end up with a binomial. It's going to have to be a special case, though. Like this was a special case up here. You end up with a binomial that you can factor just a little bit further. It's the difference of squares. So we'll go like this. We'll go x times x, 3 times 3, 1 positive, 1 negative. And now we have factored completely. So here's a couple more for you to try. Again, look at little Dory's steps here. Look for the greatest common factor first. In none of these examples we had any. And I don't think in your examples you will either. But a couple more for you to try.